In the early days of the space race, the United States faced a monumental challenge, launching its very first satellite. The world watched as the Vanguard rocket prepared for a mission meant to make history. On December 6, 1957, viewers around the globe tuned in to a live broadcast from Cape Canaveral, anticipation running high. The expectations were immense, but what happened would shock the nation and leave an unforgettable mark on the public imagination. Vanguard was the symbol of America's scientific ambition, conceived as the answer to the Soviet Sputnik. Engineers and scientists had spent months perfecting every detail of this technical marvel. The tiny satellite represented a test of the nation's readiness to enter the space age. Yet, in a moment broadcast live to the world, the rocket spectacularly failed, a dramatic and humbling introduction to America's journey into space. The Vanguard program began in 1955 as the United States sought to match the Soviet Union's early space achievements. Designed by the Naval Research Laboratory, the rocket represented cutting-edge technology, a delicate balance of engineering ambition and scientific precision. Every component was meticulously tested, from the liquid-fueled first stage to the small satellite it would carry. The program's goal was simple yet monumental: to place the first American satellite into orbit. For the engineers, the pressure was immense, and the stakes could not have been higher. Vanguard's design was unlike anything attempted before by the United States. Its three-stage rocket used a combination of liquid propellants, each stage carefully calibrated to achieve orbital insertion. The tiny satellite, weighing just under 4 kilograms, was intended to broadcast scientific data back to Earth. Every detail, from the guidance systems to the telemetry, had to function flawlessly. Failure was a constant threat, lurking in every calculation and test. As the launch date approached, public interest skyrocketed. Newspapers around the world reported on the upcoming attempt, framing it as a national test of scientific prowess. Engineers rehearsed the countdown repeatedly, ensuring every valve, sensor, and engine was ready. The excitement was palpable, but so was the tension. The program had never faced a live test of this magnitude. Onlookers at Cape Canaveral and audiences worldwide prepared for a moment of history. Preparations for launch were meticulous, with engineers monitoring weather, fuel mixtures, and mechanical systems down to the last second. Vanguard's slender frame was rolled onto the launch pad, standing as a symbol of America's hope in the space race. Cameras were positioned to capture the liftoff from multiple angles, broadcasting the event live to the nation. Every eye was focused, every heart racing, as the countdown began. The anticipation of success and the dread of failure hung over the launch site like a storm cloud. Behind the scenes, engineers worried about the smallest details. Propellant pumps, guidance circuits, and telemetry systems all had to operate perfectly to achieve orbit. The smallest miscalculation could lead to disaster, and the margin for error was virtually non-existent. Years of planning, research, and testing all converged in this single moment. Vanguard's fate would determine America's initial standing in the nascent space race. Finally, the moment arrived. The countdown reached 0, and Vanguard ignited with a roar meant to herald a new era. For a brief instant, it seemed the rocket might succeed, climbing steadily into the sky. But within seconds, tragedy struck, and the rocket faltered, tumbling back toward the launch pad. Smoke and flames erupted, leaving the world in stunned silence. The dream of an immediate American satellite was shattered in a spectacle broadcast live to millions. December 6, 1957, dawned with nerves and anticipation at Cape Canaveral. Vanguard stood tall on the launch pad, a symbol of America's hope in the space race. Millions watched on live television, eager to witness history unfold. The countdown reached 0, and the rocket ignited, lifting slowly into the sky. For a brief moment, it seemed Vanguard might succeed. But within seconds, the rocket faltered, engines cutting out unexpectedly. Smoke and flames erupted from the base as the craft tumbled back toward the pad. The live broadcast captured the disaster, leaving viewers in stunned silence. Engineers rushed to assess the damage, but it was clear the mission had failed. The tiny satellite was destroyed, and the launch pad suffered minor damage. The spectacle became an instant symbol of the difficulty of space exploration. The world watched as America's first attempt ended in dramatic failure. Public reaction was immediate and intense. Headlines mocked the flaming rocket, while others praised the bravery of the engineers. Despite the failure, scientists emphasized that setbacks were part of pioneering work. The event highlighted the gap between ambition and technological reality in the early space age. Lessons from the disaster were quickly analyzed. Engineers studied every valve, sensor, and stage separation sequence. The failure prompted improvements in design, safety protocols, and testing procedures. Vanguard would rise again, but the initial setback left a lasting impression. The launch became a defining moment in American space history. It illustrated both the perils of early rocketry and the determination to persevere. Despite the public embarrassment, the program continued, driven by national pride and scientific ambition. The stage was set for future successes in the U.S. space program. After the catastrophic first launch, engineers refused to be defeated. Every component of Vanguard was re-examined, and design flaws were meticulously addressed. Guidance systems were improved, fuel mixtures recalibrated, and structural weaknesses reinforced. The failure had been a painful lesson, but it provided invaluable data for future attempts. America's first satellite program was now a testament to resilience and ingenuity. The Naval Research Laboratory worked tirelessly to prepare Vanguard for a second launch. Engineers conducted simulations and small-scale tests to ensure every stage would perform flawlessly. The tiny satellite, designed to transmit atmospheric and orbital data, was carefully integrated. Launch procedures were rewritten, and new safety protocols were implemented. Attention to detail became the program's defining characteristic. Vanguard's engineers also learned the importance of public perception. The initial live broadcast failure had embarrassed the nation, and the next launch required both technical success and confidence building. Communications teams carefully managed the narrative, highlighting progress and readiness. Scientists balanced transparency with optimism, aware the world's eyes were still upon them. The program's reputation depended on turning failure into achievement. As launch day approached again, tension at Cape Canaveral was palpable. Every countdown sequence was rehearsed with military precision, each valve and circuit triple-checked. Engineers held their breath as the rocket lifted from the pad, climbing into the sky with renewed vigor. For a few anxious moments, history seemed uncertain. Then Vanguard stabilized, ascending steadily toward orbit, a dramatic reversal from the previous disaster. The successful launch of Vanguard 1 marked a milestone in American space history. The tiny satellite reached orbit, transmitting data about atmospheric density and Earth's shape. It became the first U.S. satellite to orbit the planet, a triumph of science and engineering. Engineers celebrated the culmination of years of work, overcoming embarrassment and setbacks. Vanguard's success restored national pride and proved the United States could compete in the space race. Beyond national pride, Vanguard provided critical scientific knowledge. Its orbit allowed measurements of atmospheric drag and insights into Earth's shape, known as the geoid. The satellite's radio transmissions helped calibrate instruments for future missions. Each byte of data expanded humanity's understanding of Earth and space. The mission validated the painstaking process of trial, error, and perseverance. Vanguard's story became a symbol of resilience and determination. From a fiery televised failure to a historic orbital success, the program demonstrated that progress often requires confronting public setbacks. Engineers and scientists had learned, adapted, and ultimately prevailed. The mission laid the groundwork for subsequent American space endeavors. Vanguard proved that failure was not the end, but the beginning of a journey toward the stars. Vanguard's success proved that the United States could compete in the space race. The tiny satellite transmitted valuable data about Earth's atmosphere and orbital mechanics. Engineers used these lessons to improve rocket design and reliability. The program established a foundation for all future American space missions. Despite early failures, Vanguard inspired a generation of scientists and engineers. Students and researchers studied its design, learning from both mistakes and triumphs. Its broadcasts captured the imagination of the public, turning space exploration into a national fascination. The mission became a symbol of perseverance under pressure. The satellite's orbit provided unprecedented scientific insights. Atmospheric drag measurements helped refine models of Earth's shape, influencing navigation and future satellite trajectories. Its radio signals tested communication systems that would be essential for later missions. Vanguard demonstrated that small satellites could yield enormous knowledge. Vanguard also taught engineers the importance of redundancy and precision. Every failure highlighted areas needing improvement in materials, guidance, and launch procedures. These lessons informed subsequent programs, including Explorer and later space probes. The knowledge gained from Vanguard accelerated America's technological growth. The program highlighted the value of persistence in space exploration. Early setbacks were public and dramatic, but overcoming them built credibility and confidence. Scientists learned to anticipate risks and mitigate failures through rigorous testing. Vanguard's journey underscored the challenges of pioneering new frontiers. Public perception shifted as Vanguard succeeded. Once mocked for its fiery first launch, the program now earned praise and admiration. Its achievements inspired media coverage and educational interest across the nation. The mission became a touchstone in America's growing space narrative. Vanguard's impact extends beyond its technical contributions. It set the stage for future satellites, space science, and manned missions. The program proved that failure could be a stepping stone to historic achievement. Vanguard remains a reminder of the courage and ingenuity required to reach beyond our world. Vanguard's journey began with a spectacular televised failure, but it ended with historic success. The program demonstrated the risks inherent in pioneering space exploration. Engineers and scientists turned embarrassment into a lesson in perseverance and innovation. This dramatic turnaround captured the imagination of the nation and the world. The successful launch of Vanguard 1 proved that small satellites could provide enormous scientific value. It transmitted data on Earth's atmosphere, orbital mechanics, and atmospheric drag. These measurements influenced future satellite missions and space navigation. The mission was a milestone in understanding how to operate spacecraft in orbit. Vanguard also shaped the U.S. approach to rocket design and testing. Failures highlighted critical weaknesses in materials, guidance systems, and launch procedures. Each adjustment and improvement strengthened subsequent programs, paving the way for Explorer and Atlas missions. The lessons learned became cornerstones of American aerospace engineering. Public reaction evolved from mockery to admiration. Once ridiculed for its fiery first attempt, Vanguard became a celebrated symbol of scientific courage. The mission inspired students, researchers, and engineers to pursue space science. It transformed the narrative of American space capability in the global arena. Vanguard's story is a testament to resilience. Early setbacks did not halt progress. They informed it. By confronting failure head-on, engineers achieved what once seemed impossible. The satellite's orbit marked a turning point in the space race and in U.S. technological confidence. Beyond technical achievements, Vanguard captured the imagination of the public. Television audiences witnessed firsthand the drama of space exploration, learning that progress often comes through trial and error. Its images and data brought distant science into living rooms worldwide. The mission inspired a generation to look skyward and dream. In the end, Vanguard's legacy is enduring. It laid the foundation for America's space program, proving that innovation requires courage, persistence, and adaptation. From the ashes of televised failure arose a triumph of engineering and science. Vanguard remains a symbol of America's determination to reach the stars.